Yeah. So welcome for the another lesson on functions and relations. Believe it or not, ladies and gentlemen, you've actually been experiencing functions and relations all along. And the way that I like introducing it, even though you have a handout, is something that you've seen before. Okay? X comma y. What is x comma y? This is called an ordered pairing. And a lot of you realize that the variables x and y, the x is the independent variable, and the y value is the dependent variable. However, in grade 11, I'm going to introduce some new concepts. The x is also known as the input. The y is also called the output. And finally, the x is also known as the domain. The y value is also known as the range. I haven't explained anything what a function is, but I like starting off with this first, even before we talk about it. Because in grade 9, you learned about straight lines, right? What's a straight line? A lot of you learned called the slope y-intercept form, or simply y equals mx plus b. Y, of course, is the output. M is the slope, x is the input that you're going to put, and plus b is the y-intercept if you have it or not. So let's give you a definition of what a function is. And it's in your package. The definition of function, it seems weird. That's my definition. For every x, there's only one y. There's all these relations that we have, and in the real world, a lot of you have a relationship with your family. A lot of you have relationships with your teacher, me. These are called relations, right? However, the definition of function, for every x, there's only one y. That's the best way that I can show you is by a couple examples. Let's take a look at set notation really quickly. A set notation is like s. And notice what I'm going to do. I'm going to write this example. 2, 3, 4, 7, and 7, 9. Notice, I do not know what actually gave me those answers. When I inputted 2, the output was 3. I do not know what input of 4, output is 7. Input of 7, output of 9. I do not know what the function is, but who cares? My question to you, ladies and gentlemen, is this set a function? Yes or no? Now, let's give a 50-50 chance.
Yes.
But this is a function because for every x, there's only one y. So 2 does not give me another answer. That's what I'm trying to get to, ladies and gentlemen. Well, I'm off screen. That's what I'm just trying to get to grasp, first of all, recognizing what a function is. Again, understanding what it really is, you'll see as we evolve. But it's a couple ways of orienting the information. Basically, from some data, right? Or maybe from an equation, or even from a graph. So let's take a look at another way that you've seen kind of information. A table of values. I'll just do one really easy. And again, notice these are the inputs, these are the outputs. And again, I do not know what gave us those outputs or those ranges or those dependent variables. Can I get a volunteer to tell me? Is this a function? Yes or no?
Yes.
Yes, it is. This is also a function. And the reason why this is a function, again, if you look at the package, it definitely gives you a definition here. A function is a special type of relation which is a set of ordered pairs in which for every value of x, there's only one value of y. I like my answer, and if you saw the PowerPoint, it would say that for every x, there's only one and only one y. So this is a relation, but it's a special relation called a function. What kind of function this is? Let's graph this one, actually. And I'm going to draw this as a sketch. And let's connect the dots, even though they're integers. From -1 to 2, 4, we get this. Can I get a volunteer to describe? What do you see as this red thing that I've drawn? Really simple, easy question. I'm off the screen. Let's move this over. Sorry, Maria. Bridget.
A line.
Not just any line. What kind of line? It is a line. What kind of line? There's 4 types of straight lines that you learned in grade 9. Sorry? Eric?
Isn't it just a line? Then there's line segments, then there's rays. That's just a line.
Yeah.
Okay, this is a special line.
The horizontal.
Horizontal line is correct.
Oh.
So if you've been paying attention, that's why in grade 9, you've actually learned functions already. There's only one exception. Let's take a look at an example with what's called a mapping diagram. So this is called set notation. This is called the table of values. You're seeing a graph, and I apologize, I have to erase this part so I can get on screen. Let's take a look at the new concept that some of you may or may not seen before. This is called a mapping diagram. It illustrates something easier sometimes. And the arrows that maps it to it is easy. This is called a mapping diagram. So let's answer the question first of all before I show you visually what this is. And again, it's 50-50 chance. Notice the definition is still on the chalkboard. Is this a function, yes or no?
No.
No, it is not. It's still a relation, right? I apologize, I'm going to say something maybe it's kind of sexist. It's just like saying, you know, this is me in high school, and I have multiple girlfriends. That's not true. It's possible. That's just, well, you guys live in exciting times right now, so maybe it's acceptable. Yeah, like we're all, it's okay. But in the definition of mathematics, this is not a function. It's a relation. Right? And if we were to graph this in orange chalk, let's see if I'm still on the screen. Yeah. What would this look like? And I'll get out of the way so I can see it. At 5, we get -1, 0, and +1. What kind of line is this? Vertical line. So it's still a line, right? And it's still going to be written as an equation, right? But this one is not a function. Not a function. It's a relation. So one more time, you've learned already in grade 9 math, functions and relations. It's just we just never described it that way. Again, it's a relationship that it can be true in mathematics. But the point is to recognize what is a function and what is not. So I'll say this mantra. Let's see if I can do it. All functions are relations. Not all relations are functions. Does that make sense? I'll say it again. All functions are relations. And not all relations are functions. So you've actually learned subtly 4 key things. How to organize information. Notice I have not given you the algebraic or the equation. We had set notation, we have a table of values, we have a graph. In fact, I did 2 graphs. And we did what's called a mapping diagram. Any questions from the class before I keep on going? So let's take a look at an equation that you've seen hopefully from grade 10. And you're going to tell me, is it a function or not? And don't get me wrong, don't feel bad. This is the whole point of grade 11. That page that you have in the handout or the PowerPoints will support you. And you have the textbook reference section 1.1, which I think will also assist you if you need to read up on it. Don't worry, we won't finish this whole thing, but I do want to finish the lesson relatively early before 12 o'clock so that, you know, it's nice and short for the rest of the class. Because it's been a long day, and I'm very, very proud of it. Can I erase this? Just want to, we have to be ready for the video. So let's give you an equation. You kind of think of the functions and equations, the relations using what's called a rule. So some of you have seen this before, x squared plus y squared equals 25. Before volunteer answers, because some students already know what this is, let's just ask you, is this a function, yes or no? Grace is shaking her head.
Yes and no.
Eric says no. This is not a function. And you're correct. Does anyone actually remember what this is from grade 10 math? Brandon.
I want to say a parabola.
It's not a problem. Thank you for playing math. But that's okay. Mistakes are okay, ladies and gentlemen. Mistakes are good. I'm glad you thought it was a parabola. It is not a parabola. Danielle. It is a circle. Not just any circle.
What's a half?
A circle
Full graph.
is at the it goes from -5 to +5 to -5. This is a circle. This is not a function. So notice what I did, ladies and gentlemen. I gave you a graph, and some are saying, well, how am I supposed to know this? Even if you gave me the graph, even if I know it is a circle. When given a graph, there is this extra test that we can determine what functions are. And I apologize, I erased the equation, erased the definition. We can do what's called a vertical line test. A lot of students know this, the VLT. And basically, the vertical line test says, if it crosses the function, let's start again. The vertical line says, if it crosses the image or the relation more than once, then it's not a function. So if you take a vertical line, and I go through here, just a second, I'm just arbitrarily choosing this. It's crossing there not once, but twice, in this case. Doesn't look like it can just be more than that. This one fails the VLT. Therefore, not a function. And you can see it in the handout. I think it says it there. The vertical line test passes through more than one point on the graph, then the relation is not a function. Okay. Let's just pause there. And notice those were the first, one of the first 5 rows here of the information there. Any questions before we get to the example 1? Oh, I didn't do the main array. We'll do that in a moment. Okay, so let's just do example 1, and I think that'll be our limit. I think I got everything out of the way. Any questions still? You just need to see this in practice. Any questions at all? Can I erase this? So example 1 says domain, arrange, and order pair. I haven't really talked about domain and range, because it's kind of a little confusing. But basically, domain and range is just an organization of whatever you present. That's all it really is. And if you really want to know, the analogy is kind of like rewriting it as a table of values or as a set notation. That's really what it is. However, there's kind of 2 different ways of actually looking at it. And we'll get to it when we actually get to the graph. So let's just get a look at example 1 together. So notice they gave you for question A, given the relations, for question A, and I'll just recopy the question. 1, 2, 3, 4, 5, 6, and then 7, 8. Technically, there should be a set, these set parentheses. Look at that. So it says for question 1, graph the relations on the given grid. So I apologize, the photocopy did not put it all through. There was actually a grid there, so if you want to do it yourself, that's fine. So 1's there, 2's there, point there, 3 is here, and 4 is here, and then 5 is here, and 6 is up here, and I'm running out of room. 7 is here, and 8 is there. So I just ran out of room. So that's part 1, you're just practicing graphics. So notice you're taking something that's written and then you're graphing it, okay? So I apologize the grid didn't show up. So for question 2, that was 1. Question 2 says, determine the domain and range. Now the domain, we tend to use capital D, and range, use capital R. Now, I understand we use R a lot as real numbers, all real numbers. It's just a way of writing it. I like actually putting semicolons, and I like putting the set notation here. And technically, we should teach you properly how to do this, so just follow along. I think you'll understand in a moment. I'll explain it in English first of all. The domain, if you remember I wrote on the first part of the lesson, it represents the independent variable or the x variables, right? The x values, right? It's also the inputs. So what would I write? Well, x is such that x is equal to, and what are the x values? 1, 3, 5, and 7. 1, 3, 5, 7. And just to cover myself, although because I think from this set notation, and all of the data they gave us, they're positive, technically you could say such that x belongs to natural numbers or whole numbers, didn't really say 0, but just to be safe, I put I for integers. Now, ladies and gentlemen, what's the most important part of this? Is actually not this x such as, it's this, right? Everyone agree? That's the most important thing, what I'm trying to get at. And again, this kind of math is weird. This math is kind of weird, ladies and gentlemen, is because it's kind of a communication question. It's not even, you're not even doing anything, you're just kind of organizing the data. Also, notice, once we ask questions like this, domain and or range, it's very difficult to go back to the original question. So meaning, once we get the domain and range, it's almost impossible to say, well, what was this question? So even given this, it's hard to go reverse. Okay. Let's see if someone actually give us the range. No pressure, and again, a lot of you realize what you're doing. Y such that, any volunteer want to try? Maria?
Y is equal to 2, 4, 6, and 8.
And that's the answer, right? But this is the most important thing. Let's just pause here for a second. Some of you are slowly understanding why I teach the inequalities. These are not inequalities, they're actually what they're equal to, right? Notice visually, and I apologize to stress this, these values are what's called discrete. I did not connect a line through it, even though you could theoretically draw a line through it, but they're not supposed to be connected. Because we just don't have enough information or data to put that. The real world application of why you're learning this is like what we're kind of doing now with facial recognition, right? Or CGI graphics in the computer world. They take key points about your face or maybe your phone unlocking, and that's what they're doing. They're taking the key features and understanding whether or not you're disguising, or maybe somebody did that Snapchat app, or what would I look like in 20 years that makes you look older or younger, right? All these filters and everything, this is what it's doing. Granted, right now in our grade 11 math, we're teaching you the basics or foundations of that so that you can do those manipulations. Right? So that's the main and range, part 1 and part 2. Any questions about that before we get to the 3 and the 4? Question 3 is really silly. Create a mapping diagram for the ordered pairs. So watch what I'm going to do for number 3. And I apologize, I'm running out of room, but I want to keep it in the camera. So what you would do, 1, 3, 5, and 7, and 2, 4, 6, and 8. And this is called a mapping diagram. And watch what I'm going to do. 1 maps to 2, 3 maps to 4, 5 maps to 6, 7 maps to 8. Now you don't have to make it that large, you can make it definitely smaller. You can be a bit more creative. And so this one, question 3, is almost analogous or almost identical to this set notation. Finally, notice, you're not really looking at 2, you're looking at the graph or the original question, or question 3. You can answer question 4, which we're going to probably stop the video. This example. Can I get a volunteer to tell us, are they representing a function or a relation? It's a function. And the reason why, I'll just say it orally rather than writing it out, this information is a function because for every x, there's only one y. Or, if I did a graph, if I drew a vertical line here, hey, it only passed me 1 point. It didn't cross more than once. Next day when I see you, unfortunately for this class here, cohort A, you're going to kind of miss the lesson live here with me, but you can continue on to the package, right, of this portion. Examples 2, 3, 4, and 5. But don't panic. When I see you again, cohort A in class, obviously on Wednesday's class, you could actually ask me some questions. Okay? We're going to stop there. That's awesome. But I want you guys to try to work. Now, I will help you guys a little bit. I want to stop the video here for everyone else because everyone's going to be able to ask me questions.